Welcome to another episode of Inside IALR. I'm Caleb. We got Daniel on production. Thanks, Daniel, for that. I'm here today with Dr. Scott Lohman, who you all have heard from before if you've listened to our podcast, who is our Vice President of Applied Research, as well as Jack He, who is the Senior Analytical Chemist here at the Institute for Advanced Learning and Research. So really since, we've been founded, well, first, thank you all for being here. Really appreciate it. Really since, we've been founded over 20 years ago at this point, there's been a big focus on research that helps industry, not just research for the sake of research, but research that helps industry. And here today, we're going to talk about the work of our chemistry lab, which I know has been a big focus from the beginning. But first, I'm going to open up to you all. You hear the words analytical chemistry. I'm no scientist, so I'm going to open it up to you all and ask, what is analytical chemistry?
Analytical chemistry is a science that is specifically aimed at determining the chemical composition of a material. All materials are essentially composed of chemicals. In the context of analytical chemistry, we specifically study, number one, the identities of the chemicals that this material in question is composed of, as well as how much of each chemicals are present in the said material.
Now, what's important about analytical chemistry and the Institute and being able to help businesses is it is a testing service. So it provides clients with data that they need to move forward. We are not doing chemistry research here, which are mixing things together to see what happens.
Science
we're
potions.
not really doing chemistry research. We are doing chemistry testing and providing that at a high level for companies at a low cost is what really makes our lab different.
Yeah. And Jack, you were talking some about that, the ability to analyze exactly what chemicals are there and how in what quantities. So break down a little bit more, what are those testing services that we offer? First, for someone who might not be familiar with analytical chemistry, and then someone maybe break it down again for someone who is, understands this more.
So basically when we work with companies, there are two pathways. Some companies have materials that they want to know what's in it and how much. But it's not something that they're interested in doing over and over and over again. So there's two types of testing that we do. The one-off, where we have companies that come in and, as I said, want to know sort of what's in there, right? It's what we think should be in there, but also for regulatory purposes or whatever. So testing, for example, soil metal, heavy metals in soil. The second type of testing we do is for companies that are interested in ongoing testing. So they have a product that they come out that they want validated. Say they're selling it on through a marketplace, and they're claiming they have a certain amount of X in their product. What Jack does is he's able to validate that and give that company a certificate of analysis, a certificate of analysis that tells them that this is exactly what you have in here. So it makes the product more valuable to customers.
Right. And specifically, I think the services that we provide can be broadly categorized into two main types. Number one is the chemical analysis, the analytical part, but the other part, which also it's also, in my opinion, an integral part of the services, method developmental processes that we provide here, which I think is what really sets this lab apart from all the other testing labs out there. Is that number one, we are committed to providing regional economic transformation. So a lot of our clientele, they would benefit greatly from having analytical labs of their own, but due to the upkeep cost being so upkeep and also the upfront cost of running a lab being so cost prohibitive, we provide our ability to provide an unbiased testing services alleviate a lot of our clients need to have a lab of running the lab of their own. But in addition, we're willing to work closely with our clients in developing methodologies on targeted analysis specific to addressing their needs. So that's the method developmental part. The testing services that we provide range from single target analysis, meaning we perform a series of procedures to specifically analyze one particular analyte or it can, on the other end of the spectrum is we provide multi-pesticide residue analysis where we can screen an output of 200 different pesticide chemicals. And then the services we provide can either be for QC or quality control purposes, either for quality control data and then the data that we provide in terms of in the form of a certificate of analysis can be used for their quality control release. Another part that we provide, which the Institute is for the past couple of years have been working closely with the USDA and VDAX in conducting compliance testing for industrial hemp. We are one of the few test labs in Virginia that can issue regulatory compliance certificates. And another part is for addressing, this is more for medium-sized companies or research groups when they have a chemical processes or a process that involves chemicals. We provide data pertaining to their chemical processes, thereby helping them making more informed decision in terms of whether or not the process that they have is going. When we can use some of the key chemical analytes as benchmarks.
Just as we talk through the analytical chemistry capabilities, it will become evident that we are focused on plant science. And we think that makes us unique. Most chemistry labs are set up for water analysis, air analysis, different types of materials. But Jack is an expert at plant science. So when you're dealing with something that's inside of a plant, you're dealing with lots of other molecules, just thousands and thousands of other things that can get in the way of analysis. So Jack's ability to do method development, to be able to see through all the other things that are in that plant to see exactly what you're looking for is really what makes us unique.
When you're talking about method development, does that mean someone is coming in and saying, I need to test this, we need to figure out a way how to test this? Is that essentially what's happening there? What does that mean, method development?
I would say on a broader just an overview is that when someone comes in, no two plants are alike, no two matrices are alike, so it could be anything that comes in the door, there's not just one simple test we just put into a machine that tells us the answers. Jack has to go through, and if it's if it's a woody material or versus a something like hemp that's softer, there's all different types of methods that you have to go through to get the extraction process that Jack can dive more deeply into. But to be able to go into that, all those different types of materials, it takes individualized testing to do that. So the method development is almost required for every single test that we have come in here. So it's not just something that we can just do. Now, with industrial hemp, for example, we have already developed all those methods. So Jack's able to know exactly what to do when the hemp comes in. But oftentimes we're presented challenges for different types of plants, different types of materials, all sorts of things. So Jack is able to address all of those, but it's a complicated process.
I mean, we've been talking about the lab a lot, and I've been in there. I don't know I don't fully understand what anything does in there, but all the machines look very cool. Explain to us what some of the I guess machines or equipment that we have in the analytical chemistry lab. First, big picture for someone who has no clue what any of this stuff is, then a little more in depth for someone who might be more familiar with this.
I want to start off by saying, as a chemist, I've been very fortunate to be able to get my hands on some of the most elite, sophisticated instruments that's commercially available in this industry. And our big fleet of instruments mainly consists of three types of instruments: the liquid chromatograph, the gas chromatograph, and also the inductively coupled plasma mass spectrometer. So
I couldn't say that. If you gave me 5 times to try to remember how to say that word, I would not get it.
It's short for ICP-MS.
Yeah.
It's for
we love acronyms
analysis.
here. ICP-MS. All right, we'll stick with that.
Oh, okay. So to break it down, I would say 90 to 95% of our work revolves around liquid chromatograph, because that's typical. Most of the samples that come into the lab are aqueous soluble. So that's why liquid chromatographs is the most suitable technique for analyzing the samples. There's actually a two-piece to each one of these instruments. Number one is the chromatograph is where the separation takes place.
Okay.
So if you imagine a sample of Coca-Cola, the sample may look homogeneous, but it's actually composed of various different chemicals. There's the caffeine, the sugar, the carbonate, and all the other preservatives. So in order for us to provide an analysis, let's say someone wants to analyze how much sugar is in a can of Coca-Cola, we need to separate various different chemical components. That's where the chromatography, the chromatograph piece comes into play. It's a very important part of the chemical analysis. But also equally analysis is the detector part. And our instruments are all coupled to a mass spectrometer. There are various detectors used throughout the industry. Mass spectrometers are currently the most advanced technique that provides unparalleled accuracy and precision and also unequivocacy. So we have two types of mass spectrometers for our liquid chromatograph. One of them is triple quadruple mass spectrometer, which is our main workhorse. It can analyze samples in the parts per billion range to even to parts per trillion range. So
that doesn't even sound real.
The capability that it affords us is to go into to detect really trace amount of analytes. So when it comes to compliance testing, becomes very important. In fact, most of the compliance tests, they require you to have that sort of capability. And then another capability that it affords, the mass spectrometer affords us, is it looks at molecular fingerprints, not just not just a retention time or absorbance, which is typically how the cheaper analytical methods are. We look at molecular fingerprints, so it's a lot more precise because it's oftentimes in some cases you may have two different co-eluting you have two different compounds. We call it co-eluting. So you can have two compounds elute at the same time and have similar absorbances. If those are only the matrix you're going to, in terms of identification, that you may have either false positive or false negative. Whereas mass spectrometer, we're looking at molecular fingerprints. So it's possible, but it's more rare for two different chemicals to have almost identical molecular fragmentation patterns. So the test becomes a lot more unequivocal. And that's the triple quadruple mass spectrometer. Another different type of mass spectrometer that we have is the quadruple time of flight. So it's more useful for structural elucidation. So someone has a compound or have unknown chemical processes that can generate some novel compounds or unknown compounds. We can deduce some of the structural information for our client. But having said that, there are more sophisticated techniques out there, such as the nuclear magnetic resonance. But the QTOF, the quadruple time of flight, will give our client a starting point, and that covers the liquid chromatograph part. There's also the gas chromatograph. So what that does is you have compounds that are that falls under the volatile side, and those are not really amenable to be analyzed using liquid chromatograph. And so that's where the gas chromatograph comes into play. So a lot of the gases and also compounds that under room temperature exist as a vapor, those can be analyzed using the gas chromatograph. And the last piece, the long acronym ICP-MS, that's for the elemental analysis. Going back to what Dr. Lohman said, soil analysis, testing heavy metals in soil or in plant. That's the piece of instrument that we use.
So on a very basic level, basically what you're doing is separating all of the different elements of any material that comes in to its most, basically to the chemicals, as you said in the beginning.
Correct.
And then even if for those you might not be able to identify, you can at least provide some level of information about what those chemicals are.
Correct. And well, that's going back to having mass spectrometers. Mass spectral data. The advantage of having that is you can do a library search, because if there's an unknown compound that has been studied by somebody in the world, some research group in the world, they have published the data. Chances are, when we take the molecular fingerprints, we can run a library check, and then we can see whether or not this is something that has already been done, or if not, then we may be able to find a compound that's more closely related to the unknown that we have.
Yeah, that's really cool.
Just a basic overview would be we can test things in water, in air, and in solids, and through different pieces of equipment. And that would be the high level overview.
Right.
Uh-huh. Jack, you said earlier that you're feel very fortunate as a chemist to work here with the equipment that we have. How does what we have compare to what other labs have, or what other industries have?
Well, I want to go back saying that prior to joining this wonderful organization, I was working in a pharmaceutical company, and in a pharmaceutical QC lab, we have over 100 liquid chromatographs. The liquid chromatographs alone, there's over 100 of them, but they are how should I say? They're more like the lower end of the instruments, because so number one, the instrument we had, they were called a high performance liquid chromatograph, versus the instrument that we have here is called the ultra performance liquid chromatograph. It's not only in the name that makes it special, but also the techniques, the technologies that makes the current the latest generation instruments. Mm-hmm. From a throughput perspective, ultra performance versus high performance. Ultra performance can compress analysis to about half the time easily, compared to conventional high performance or other conventional liquid chromatograph method. And then another advantage is from environmental conscious perspective. High performance liquid chromatographs consumes much less solvent, much less consumables, such as chemical reagents and solvents, which we call the mobile phase. So it's not only more cost effective, but also better for the environment. Mm-hmm. And also another part that really makes our instruments stand out from the other, not only the pharmaceutical labs, but also other testing labs out there, is the mass spectrometers that we have. A lot of the universities and pharmaceutical labs, they envy the mass spectrometers that we have. To go into more detail, the one that we have, our main workhorse is the TQ-XS. It's one of the most advanced triple quadruple mass spectrometer that is commercially available.
Yeah, no, that's what I remember hearing you say that higher education institutions and pharmaceutical companies would all be jealous of the equipment that we have here. So I think that's pretty cool. And in the last episode we were talking with Butch in the Industry 4.0 lab and all the automation and stuff. And I think that's really cool just to see in every part of our organization how we're pushing for that top tier technology, and not just just to say we have the cool toys, but because those are the ones that can work the best, and we're all about driving innovation and things like that. So that's really cool. You mentioned hemp, talked about clients sending us products. I know I've heard you both categorize sort of the clientele of this lab into three sort of primary groups, being sort of local growers, government contracts, and then even just, private industry. Can you guys break down sort of what sort of services we would provide for each of those clients?
I'll start out with just saying that in general, we work with folks from an individual grower, as you mentioned, small companies and startups, to some of the biggest companies that you know of, multi-billion-dollar companies, because of their capabilities are so specific and related to plant science. That makes us really unique. So I wanted to just sort of throw that in there.
And we can't say most of the names of the multi-billion-dollar companies because we have non-disclosure agreements.
Exactly.
So, sorry.
Exactly. But it's important to note that they do come to us for testing services, and Jack helps out in many different ways. We also help companies that are expanding or going into new areas with testing, and that's some really exciting stuff going on there, which I also can't talk about.
What's the number of non-disclosure agreements we have now?
It's about 65 non-disclosure agreements.
So that's 65 separate organizations that we're working with that we are doing some level of testing for.
Yep. We have an agreement to work together. Yes.
Yeah, that's pretty awesome. That's a good number.
Okay, so the three types of our clientele, and then the services that we provide. And number one is the biggest part is the confirmatory testing. So when this can be either an individual grower or a nutraceutical company when they think they have, let's say they want to verify their product contains X number of A, and we can provide the test to verify whether or not what we see in their sample matches their label claim. Or if a grower is going back to the industrial hemp example, when growers growers get paid on how their crops is being evaluated based on how much percent. Let's say if they're growing for CBD, the crops being valued based on the percentage of CBD that's present in their sample, but also the other minor cannabinoids. So thus, we can provide cannabinoid profiles analysis to give them a breakdown of all the key cannabinoids that basically will be their crops will be judged based on the percentage or the profile of those cannabinoids. Those are the confirmatory testing. Another part is compliance testing. So this goes to mainly for the industrial hemp. The 2018 Farm Bill mandates in order for a crop to be categorized, to be considered as industrial hemp and not marijuana, the threshold of delta 9 THC needs to be below 0.3%, and if the percentage goes above that, there could be some legal repercussions. So this, and we provide this lab institute. The institute is entrusted by VDAX and USDA to conduct compliance testing because this growers' livelihood is on the line. So we are very we're very proud to be selected as one of the few labs that can be entrusted with this type of testing. And then the third type is really providing, well, it goes hand in hand with methodology development, but also providing data mainly for process, for either for process optimization or for providing data that can be used by our clients in addressing their process. So it's really the main three types: the confirmatory, compliance, and method development or process optimization.
So I know, our research division here, and as you mentioned earlier, Scott, this lab doesn't do as much. This is not a research chemistry lab. This is a, more of a testing research. I mean, a testing chemistry lab. But this falls under our applied research division, which, as you've talked to me about, is, more about things that can be applied right now, as opposed to things that might be cool later down the road. How does this lab fit into that mission, number one? And then two, I mean, sort of related, how does the analytical chemistry lab support our other research focus areas like, controlled environment agriculture and biotechnology with plant endophytes?
So first, I'll define the difference between applied research and fundamental research. I think that's important. Fundamental research is what really happens a lot at like a Virginia Tech or UVA. Federal funding funds a lot of fundamental research, so NSF, NIH, and others, and that research is what a typical professor at one of those universities would use to build their career. So there you're looking at things that really can be important, maybe 5 or 10 years out. They can be the basis for applications, but they really don't affect an industry or help an industry right away. What they can do, though, is they can build data for applied research. And that's what we're really focus on here is applied research and translational research. So applied research is where we're looking at things. How do they affect something? How can it be used with the company immediately? How can it transform agriculture tomorrow? And things like that. And translational research is really how can it be used the next day in industry? How can it be plugged in right away? So we really focus on that area between applied research and translational research. And Jack's work, while it's not necessary, I say it's not research, but he does have research components in it, right? A great example, a couple examples would be for a plant endophyte research center. One thing that we're looking at is how to use microorganisms to capture nitrogen from the air. The air we breathe right now is about 78% nitrogen, and plants can't use any of it. Nitrogen is the number one fertilizer that it takes for plants to grow. It's the most costly fertilizer. It also has environmental damages. A lot of the nitrogen that you put on a field ends up into the stream or ends up going back into the air. So for us to be able to utilize the microorganisms and bacteria specifically are the only ones that can translate and make that nitrogen in the air available to plants. It's through a complex process called nitrogen fixation. It's the most energy taxing reaction in Mother Nature. And but because they're able to do that, and we study the bacteria that live inside of plants, imagine one of those bacteria being able to hand the plant nitrogen directly from the air and eliminating the most costly and one of the most damaging fertilizers in the industry. Jack is now developing a method to test for that nitrogen fixation. It's a specific test that he can use to see if our bacteria are indeed fixing nitrogen from the air. And that's a good example of how he's supporting the research that we do to really then be able to offer the industry something special. In the controlled environment ag, our analytical chemistry facility has looked at different nutrients that are in the solutions and cleaning materials and how well the cleaning materials disappear. So Jack supports not only, of course, the industries that he works with directly, but also our overall research program. And when you combine our controlled environment ag work, which is, of course, indoor growing, with our analytical chemistry facility, as well as our capabilities in biology, molecular biology, microbiology, plant tissue culture, it really makes their overall center something really unique in the U.S. Because we have all these capabilities under the same roof, that's something that universities don't typically have. They'll be in silos. The chemistry department's over here, the biology department's over here. They don't talk to one another. But the fact that we have everything together enriches all of our programs.
Yeah, no, that's really cool. And I think cool to see the diversity of what y'all's work impacts, that it's huge, giant companies that we can't talk about their names, but I mean, as you said, multi-billion-dollar companies that we're working with and helping them improve their products and qualify their products versus the local grower who lives down the road who's, needs something tested, that we can do everything in between. And whether that be, as you said in the beginning, somebody needs one thing tested real quick, they send it over, they're done, or versus working that longer relationship working with clients. I think that's really, really cool to see the role that this analytical chemistry lab plays, not just in Southern Virginia. I think that's, in a lot of our communications these days, we say our mission statement is to be a regional catalyst for economic transformation in Southern Virginia. But that's really going beyond that in a lot of our different programs. And I think this is another great example of that. But that's all the questions that I have. I really appreciate you both taking the time to talk about this. Is there anything else that you would want to add, or any parting thoughts you would want to share?
Just the importance of letting folks know that what we do, and that Jack's Lab is open to help anyone. It doesn't matter whether it's somebody that's an entrepreneur with a new idea, or a big company in the area that may not think that that we can help them out, but we may be able to help them out. Mm-hmm. Just contact us, and we'll be happy to talk to them. And if we can't help, we can probably send them in the right direction through our partnerships with Virginia Tech, NC State, and others. But we're just always looking for folks to help out and partner with to help transform this region.
Well, I mean, we greatly look forward to providing our technical expertise to the region and to whoever may need our service. Mm-hmm. And happy to be of service.
Yeah, no, absolutely. Well, thank you both for being here. I really appreciate it. Mm-hmm.
Megabytes, IALR's on-site cafe, features everyday favorites, convenient ordering options, and an eager staff ready to welcome and serve you. Our enticing menus offer something for everyone, from a fresh, well-stocked salad bar, wraps, sandwiches, and our rotating hot buffet offered on Tuesday, Wednesday, and Thursday. Megabytes is open Monday through Friday from 9:15 a.m. until 1:30 p.m. To view menus and for more information, visit IALR.org/megabytes.